All right, so yesterday I said we were going to talk about relative humidity some more today. We did an activity where you calculated the dew point. How did we find the dew point in the room here? It involved using a metal can. Anybody want to help Donovan out? Dew forms when you reach the dew point, right? So what do we put in the can to get it cold enough in order to form dew on the outside? Yes. Ice and water. Remember that now? And as soon as you saw condensation on the outside of the can, you had to read the thermometer and tell me the dew point. Yes? And then we use that to find the relative humidity. So you had to know the room temperature. I'm going to give you these numbers. And you had to look up its capacity at that temperature for how much water it could hold. And it was 15 for this temperature. You don't have to look that up. You're going to get that. What you're not going to get is the equation. So you either have to look it up. Actually, I guess you're going to have to look it up because I told you to shut your computers. You can't write it down. You could if you want to. Open it again and write something. In this instance, we found a dew point of 10 degrees. And you have to look up the capacity, which was 7.8, but it's equal to the specific capacity when it's the dew point temperature. So we've got our 7.8, we've got our 15. You plug it into the equation here. Specific humidity was 7.8. The capacity room temperature was 15. You divide them, multiply that times 100. You wind up with 52% relative humidity in this example. It's going to be different numbers, but the same kind of a process. I'll give you the values you need. You just have to plug and chug on the equation and get an answer. Hopefully the right one. What else do I want to talk about? Nothing about that. That's all. Nope. So, let's see where we are here. We talked about dew point. Talked about all that. Okay. You did some interactive weather activities. One of them was making your own thunderstorm. To get the strongest thunderstorm, how would you describe the temperature high up and the temperature at ground level? Are they the same or different? Let's start there. They're all different. Where does it have to be really, really cold? High up or down to the ground? Think about severe thunderstorms and what they can produce that can like put dents in the roof of your car. That'd be hail. So to make hail, what's it got to be up there? Really cold or warm? Really cold. And at the surface, then, if you're going to have a big temperature difference, it's got to be warm, right? So that's what you need for a strongest thunderstorm. Really cold up high, really warm and moist down low. You get your strong thunderstorms. Did some things with hurricanes. Similar stuff because they're basically lots of thunderstorms all piled up together. Yeah. But they form out in the ocean. But where do they form? Where the water's cold or where the water's really warm? Raise your hand if you know. Haley, really warm. So tropical regions. There were some along the top, some locations that you never got any hurricanes. It's too cold up there. Other than being really warm. What are the winds like? High or low? Yes, ma'am.
Low.
Low winds. And what's the humidity like? High or low? High. High humidity, warm water, low winds, and you get strong hurricanes. Anybody here ever been in a hurricane? I'm crazy. I kind of like to be in one sometime. Kind of like when I was in California, I was talking to other teachers there and it said, it'd be really cool if we had an earthquake. I've never been in one before. And they were like, are you crazy? Just a little one, not a big one.
Very fast, the one before.
Yeah. What?
Sorry.
You're just laughing because you think I'm crazy?
No, I said my mom was in one and then she laughed and said that's good.
Oh, all right. We also talked about how climate change impacts human civilizations. And you had to write a little paper about the Mayans. Why the Mayans die out. You remember? Well, actually, they didn't die out, but their civilization collapsed. How about Miss Allen?
I really don't know.
Really don't know. Did they have enough food? Yes or no?
Probably not.
Probably not. What could happen to make less food grow? Think about what you need to have food. When you're growing food, what do you need?
Water.
Water. So was there possibly a drought?
Yeah.
Yeah. You remember that now? Maybe? A little? All right. Yeah, severe drought affected them. Same with the Anasazi. Yeah, okay. We also learned how we can tell what temperatures were like in the past. Use these little teeny tiny protozoans called foraminiferans. And you had to graph some data about their shells. Did they coil to the right when it was really cold or really warm? In other words, which one did you have to graph? The right coiling or the left coiling? It produced this really low period for about 50,000 years, really cold weather. They were the right coiling. You didn't have to graph the left coiling. All that's out there on your Google Drive. How's our planet get warm? What do you think, Paige? How's the Earth heat up? Bunch of people light fires? No. What keeps us warm? Come on, you can say it. 3 letters. Starts with S. The sun. Yes, the sun keeps us warm. Teaser. I'm doing that. A little, not much. Okay, so the sun heats up the earth, and does it heat the ground or does it heat the air with the sunlight coming in? What do you think? Now, do I say it this time?
Ground.
The ground. Because shortwave solar radiation passes right through the air, but it gets absorbed by the ground. So the ground heats up, not the air. Not that way. What heats the air? What's the troposphere, the warmest, closest to the ground? What's heating it? The ground. Long-wave Earth terrestrial radiation being re-emitted. That stuff gets absorbed in the atmosphere, heating it up. Not all of it, of course. Some goes back to space, but our air is transparent, no sunshine. The stratosphere does warm up because of the ozone absorbing UV, but that's an exception. Most of the radiation hits the ground, heats that up, and then that infrared energy heats up the air for us to be comfortable. Except for on mornings when it's 38 degrees outside. Brr. They got to prop open the door in the hallway there for the bus people. It's freezing out there. Do temperatures every year, average temperatures, vary from year to year? Or are they constantly going the same direction? They go up and down, right? What's the overall trend? We have climate change going on. People all call it global warming. So what's the overall trend? Global warming. Warming. It's going up. Yeah. All right. If we had a 10-year period where it started going down, that'd be pretty exciting, but I don't see it happening in the near future. Unless the sun goes dim or something. That'd be a sad day. Now, we want to limit carbon emissions. Countries get together, send leaders to big meetings and discuss all this and try to make treaties and things to cut carbon emissions. If we cut all carbon emissions today, Would it start cooling off tomorrow? No. Why not?
Because there's already carbon in the air.
There's already a ton of carbon in the air. You have to let nature take its course and start drawing that carbon out. Then things will start going down slowly. Took us a couple hundred years to put it up there. How long do you think it's going to take it all out? Thousands. Yeah. So our future is a warmer planet. No question about it. But we're smart people. We can learn to cope with it. You got legs. If you get too hot, just walk north, right? Hope to live with the polar bears. Just a little advanced warning there. They'll be looking for food since they can't hunt on the ice anymore. Bring it on, right? Yeah. That's really about it. Again, don't just try to do this cold. You really should be methodical and look through your Google Drive, looking up specific words and stuff you see if you don't quite understand what it's talking about, and you can find things that we've done that relate back to it. And you should do all right.